Welcome back. In this video we're going to return to arrays and pointers. This is quite a long topic, so we'll be doing this for a little bit. And in this video I'm going to combine a bunch of things together to hopefully speed some of this up. So first things first, we've got our declaration of an array. Now if we remember back to our drawing of our memory, with our arrays we're guaranteed that each element will come one after each other in memory. Okay, and this is called contiguous memory. Okay, so let's draw that in. Now we're also assuming that we've got a 4-byte int. Okay, so for this array here, it's of size 5 and we've initialized it to the values 1, 2, 3, and 4. And 5, sorry. Alright, and we can also draw the box and pointer diagram of that. So we've got something called array. So array, we've got that little pointer to the start of our array. We've got array referring to the whole array. They're ints. And we've got 1, 2, 3, 4, and 5. Now we then get to create 2 pointers, so we'll do that right now. So I'm going to draw that with these 2 here. Okay, and we've got pointer 1 and pointer 2. I'm just going to write I star rather than int star. It's clear from the context what I'm referring to. And the first one's pointing at the second element. And the second one is pointing at the 4th element. Okay. So I know we've talked about this before, but just be careful. Remember that it starts at 0, the indexes. Alright, so the next thing is we've got pointers here as a Boolean expression. We're using a relational operator. And so we're saying, is pointer 1 greater than pointer 2? Now, normally that wouldn't make too much sense because we don't usually know where something is in memory. And so comparing pointers is usually not very useful. But with an array, it actually may be useful because we know that the memory is in order. So it means that this address is guaranteed to be smaller than this address or this address. Okay, so we can actually compare these. Okay, pointer 1 is at some earlier address. We know that because our memory is in order. Okay, so let's say this is address, let's say 4, this is address 8, this is address 12, this is address 16, and this is address 20. Now I've got it in decimal rather than hexadecimal, just to help be clear. And I'm going up by 4s because obviously there's 4 bytes each time. Now we can easily see that for these values here, that pointer 1 would be 8 and pointer 2 would be 16. Okay, and so we could see that this is false and would result in a 0. Now the values don't really matter, okay, because they're arbitrary. We don't know where exactly in memory, but we do know that this occurs beforehand, okay, because of the way the memory is ordered. So regardless of actually knowing the values, we know that this is false. Okay, so we get a B here. So for example, you can check, is it less than, is it greater than, is it equal to, is it not equal to, and this is helpful when we're using arrays, and we'll see some uses later on. Okay, but you can compare which pointer comes after which one, and this might help you know where you're pointing, okay, because it may not be clear after you do a bunch of operations, okay, because we're actually going to start moving these pointers around. Alright, so that's the first thing. Now we get to the second thing. So here we've got two different things happening. Okay, so we've got this int test1, int test2, and on this first expression we've got dereference pointer1 in brackets, meaning do it first, plus 2. Now we remember that dereferencing means just follow the arrow and get the value. Okay, so we get the 2. Then we add 2 to it, so we get 4. Okay, so test1 has a 4 in it. Okay, and that's fairly clear on some of the stuff you've done already. But the next one is a lot more interesting and is extremely important. So here I've got dereference pointer 1 plus 2. Now this here may be confusing because this here is an address and we want to add 2 to it, which your brain would tell you that if the pointer's currently here and we added 2, that would bring it to this address, which is not right at all, because why would we want to go into the middle of a value? So when you add to a pointer or subtract from a pointer, what actually happens is it's actually doing this. Oops. Size of. Now, this pointer's pointing to an int, so it will actually do this. So size of means the size of the type. So it's actually going to increment by 4 each time times 2, meaning that it will increment over this and give us this one, and then times 2, which will give us this one here. Okay, so when you're incrementing pointers, it's based on the type that it's pointing at. Okay, so we've got an int star here, so this is going to be times by size of int. Okay, so this works with addition and subtraction. Okay, and this is one of the powers of pointers, and this is called pointer arithmetic. Okay, so when you add 2, it doesn't put you in the middle of a value, rather it brings you to the next value in your array, or the next value in your array. Okay, so plus 2 would be 4 here. Okay, so we get this address. Okay, we get the address of this one. Okay, so we're looking at this one. We're not changing the pointer, but we're just looking at it. Okay, dereferencing that gets the value 4. Okay, so this whole thing here evaluates to 4. Okay, now this is why it's really important that you give the right pointer type here, because pointer arithmetic won't work otherwise. Okay, so if I accidentally put short here, I would have got a garbage value because it would have been in the middle of one of my array values. Okay, so keep in mind that when doing pointer arithmetic, it's incrementing by the size of the type it's pointing to. Okay, so if I go plus 2, it's actually plus 2 times 4 in terms of memory addresses. Okay, 4 because that's the size of an int. If we were using a short array and I had a short pointer, it would have been plus 2 times 2, because a short is 2 bytes. We'll do a full pointer arithmetic example in a future video, but try and get a grasp of this because it's really going to be very helpful in your assignments and your lab work, and usually it's a question on the exam. Now, you can't do multiplication or division to a pointer. You'll get an error, but you can do plus and minus. You just got to remember that the pointer should be pointing to an array. You don't want to go past the array, and we'll talk about that. And you don't want to go before the array either, because if you dereference something outside of your array, then your program might crash. Okay? So, very important. Test these out yourselves. Try changing some of these values, keeping in mind that it can't go further than plus 3, okay? And it can't go less than minus 1, okay? So have a play with those and get a kind of idea of how that's working. The other thing you can do is use %p and print out the memory address, and you'll see that you'll add 1, but it actually adds 4 to the memory address. Okay, and you can validate that yourself. Okay, if you're not sure, just ask and we can do another video on that. All right, we then get to passing arrays into a function. So I'm going to not worry about test 1 and test 2. And I'm not going to worry about pointer 1 and pointer 2 at this stage, because they're not used for this example. Okay, so you can just imagine the problems now. Something like I can't see. Something like that. Okay, so I've just got rid of everything because we don't need it for this next example. So what you can see is we declare our array and then we call this function. Okay. Now we also don't need that anymore. We don't need this anymore. So I'll just get rid of those. Okay. So what we're looking at here is we've got a function, and you'll notice that there's a pointer as one of the arguments to the function. Okay, this is really important because when we pass arrays, we're actually passing a pointer, and we need to be really careful about this. Okay, so let's have a look at this again, but this time I'm going to draw the scope of our functions. So this is main. Okay, we declare our array, and we can see that here. We then call this function. Okay, so I'm going to call this function. It's called mean. First thing it does is it creates a pointer. The pointer is called values, and it's an int pointer, and we also create this n. Okay, so n is an int, and then we look at what's passed. So the first thing that's passed is array. Now if we remember back, that's the pointer to the start of the array. So values is past that memory address as well. So values is actually pointing at the start of the array. And n is past 5. Okay. Now, what you'll notice here is that mean never actually gets the function itself. Okay, it just gets a pointer to the function, meaning that we're actually changing the array in main, and means that we don't need to return the function, but we also need to be careful because whatever happens in here is affecting what happens in here. All right. So after this, your array might be different if you decide to change these values. All right, we are calculating the mean. So we've got this I variable for our iteration. We've got this sum. Okay, I'm not going to worry about the calculations of this. We can have a look at that in the next video. But what you notice here is we've got values and then a square bracket I. But values is an array. Well, the square bracket is actually just dereferencing. Okay. When I see, for example, A2, all we're actually doing is dereference A plus 2. Okay. When I say values I, all I'm actually doing is dereference values plus I. Okay, they're the same thing, right? This is just a nicer way to put it. Remembering that this is also doing a little bit of a times size of the type that it's pointing to. Okay, and we have our bracket operator and how it actually works. Okay, so this and this are equivalent. Okay, so I might make that a little neater, maybe not. Values plus I, okay, times size of int. Okay, remembering if I plus 1, it's going to times it by 4 so that I move the correct amount of spaces to the next one. So you can see here we start at I is 0, so we go values plus 0 times 4 is just the same memory address, and we dereference it, so we're talking about this one. Okay, so values, let me draw it here, values 0 is the exact same thing as dereference values plus 0 times 4, okay, where that times 4 you never actually write. Okay, the times 4 is implied and the computer will do that. Okay, but we can see that that would give us a 1 with either one of these. Okay, so I'm using the pointer here though to get that 1. If we now make this a 1, so I increments to 1, we now have values plus 1 times 4, which should move us to the 2. Okay, we're dereferencing, so we're getting the value. Okay, now in this, we're not actually moving the pointer itself, we're getting the value and then just storing it or doing something with it. In this case, we're adding. Okay, we're not incrementing, we're adding to the sum, so we're accumulating. Okay, so this concept can be a little bit difficult to wrap your head around, and it's best to get some practice. But basically, what it means is that if you've got a pointer to the start of an array, you can just use these square brackets. Okay, so if you make a pointer to the start of the array, you can use those square brackets. All right, that's it for this video. We'll get into more pointer arithmetic in the next coming videos. Thank you.